Section 6.7. Calculating the change of the Gibbs energy for a chemical reaction. So how do you calculate the change? Well, it's always the final state minus the initial state. The final state is the products. The initial state is the reactants. Therefore, we just need to look up the Gibbs energy of formation for the products and then subtract the Gibbs energy of formation of the reactants. So pay attention to the superscript over here, not in the superscript refers to the standard state. And usually the Gibbs energy of formation of the chemicals involved in the reaction is given for 1 bar pressure and 298 K. What if we need to know the Gibbs energy of the reaction at a different temperature? Well, first we need to look at how Gibbs energy of reaction changes with temperature. We can use this equation. Assuming T1 is 298 K. This delta G of R is 298 K data. And if we know the value of the enthalpy of the reaction, we will be able to determine the Gibbs energy of reaction at temperature 2. So this equation tells you how to determine the standard Gibbs energy of a reaction at an arbitrary temperature, given the Gibbs energy of reaction at 290 K and also given the enthalpy of reaction at 298 K. This equation assumes that this enthalpy of reaction remains constant between the room temperature and the target temperature T. When can we make such assumption? It's very simple. This enthalpy of reaction does depend on temperature. The dependence is actually Cp dt. So the enthalpy of reaction at temperature T is equal to the enthalpy of the reaction at the room temperature plus the integral of Cpm dt. Delta Cpm dt. Delta Cpm is the Cpm of the products minus the Cpm of the reactants. Delta Cpm is usually small. Therefore, within a moderate temperature range, we can assume the enthalpy of reaction is a constant. Even if in some other cases the delta Cpm value is fairly large, if the temperature range is small, still we can assume the enthalpy of reaction remains roughly constant within that small temperature range.